If Roman arches were symbols of strength, then Roman aqueducts were the veins that kept an empire alive. These monumental structures carried fresh water from distant springs, rivers, and mountains directly into the heart of Roman cities, fueling public baths, fountains, private households, and even lush gardens. For a civilization that placed such importance on hygiene, health, and civic life, aqueducts were more than mere infrastructure. They were the lifeblood of urban Rome. What makes aqueducts so astonishing is their apparent simplicity. At their core, they operated entirely on gravity. Roman engineers meticulously surveyed landscapes to ensure a continuous, gentle slope that would allow water to flow steadily for dozens, sometimes even hundreds of kilometers. With gradients as slight as a few centimeters per kilometer, the aqueducts delivered massive volumes of water without pumps, motors, or modern machinery. This mastery of surveying and slope control remains one of the most impressive feats of Roman engineering. Construction involved a remarkable blend of practicality and grandeur. In flat areas, aqueducts ran underground through tunnels, keeping water cool and protected. But when valleys or uneven terrain stood in the way, the Romans raised their channels onto towering arcades, long rows of arches stacked sometimes 3 levels high. The Pont du Gard in southern France is a spectacular example, a 3-tiered aqueduct bridge soaring nearly 50 meters above the Garden River. Built in the 1st century CE, it still stands today, a fusion of elegance and raw functionality. Inside, the water channels called specus were aligned with a special waterproof mortar to prevent leaks. Many were even covered to protect the supply from contamination. At regular intervals, the Romans constructed settling tanks to remove sediment, ensuring clean water reached the city. By the height of the empire, Rome itself boasted 11 major aqueducts, delivering an estimated 1 million cubic meters of water per day. For perspective, that rivals the capacity of some modern municipal water systems. But aqueducts were not merely technical marvels, they were social and cultural revolutions. Public baths became gathering places, fountains decorated city squares, and households gained unprecedented access to running water. In many ways, aqueducts shaped Roman identity, the ability to command nature so completely that rivers could be bent to the service of civilization. The construction process also reveals the Romans' organizational brilliance. Teams of surveyors, masons, and laborers worked in unison, often over decades, guided by precise instruments like the chorobates, a type of leveling device. Once complete, aqueducts required constant maintenance, cleaning, repairing leaks, and ensuring uninterrupted flow. The fact that some aqueducts still carry water today is a testament to both their design and upkeep. What's striking is how much of this knowledge faded after Rome's decline. Many medieval cities lived beside ruined aqueducts but lacked the expertise to repair or replicate them. Instead, they reverted to wells and rivers for centuries. It wasn't until the modern era that large-scale gravity-fed waterworks re-emerged, often inspired by Roman precedents. The lesson of the Roman aqueduct is timeless. Innovation doesn't always mean complexity. By working with nature's simplest force, gravity, the Romans achieved something extraordinary, a sustainable, efficient system that has endured for millennia. Their aqueducts remind us that true engineering brilliance lies not in overpowering the natural world, but in aligning with its laws to create something enduring.